Good morning, this is Mr. Sumter on our first e-learning day. This is January the 12th, Tuesday. I'm using an iPad to record this, so it might be a little shaky, but I'll do my best to hold it steady for you. Today's lesson is over 6.5. Basically, it's a converse lesson of yesterday. Pretty much everything's going to be opposite. So yesterday, we were given the properties of rectangles and rhombuses and squares. Today, we're going to prove, given certain conditions, that the shape is a rectangle, a rhombus, or a square. So, as you can see here in my first note, using conditions to prove a parallelogram is a rectangle, rhombus, or a square. The first thing you must know is that it must be a parallelogram to use these conditions. So you have to go back to what we learned previously in the chapter about what makes it a parallelogram, but it has to be a parallelogram first before we can use these new conditions from this lesson. As I said earlier, this is basically opposite of what we learned in lesson 6.4. So keep that in mind. So again, 6.4, we learned that a rectangle was a shape was because if the diagonals are congruent. Today, if we know it's a parallelogram, if we know that it's a parallelogram with the diagonals are congruent, then we can prove that it's a rectangle. So again, it's just opposite of what we did yesterday in class. For a square, to prove a square, you must prove the shape is a rectangle and a rhombus, okay? Because a square meets both those parameters. And keep in mind, basically what you need to do is use the diagonals to prove. Okay, remember for the diagonals, it have to be congruent diagonals and perpendicular diagonals. So using slope and also using distance formula, you can tell if they're congruent and if they are, in fact, perpendicular, kind of like we talked about yesterday. The first problem that you have from the chapter is on page 422. I'm just using the examples, not the ones in the, not the examples in the first part, but the actual problems from the text. So page 422 in your book, this is a story problem. And it talks about a garden club wants to make sure that they have a square plot for their garden, things like that. And so how can you prove that it's a square? Again, to make sure that it's a square, it just has to fit both those conditions. The diagonals must be congruent and perpendicular to be a square. And so basically that's what you'd put down to make sure you can guarantee that it is a square. The next kind of problem you're going to come across in your homework, you're going to say, determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. So they're going to ask, is this shape a rectangle? Is this shape a rhombus? Why or why not? Is their case valid? And so on this first one, we've got A, B, C, D. And it says AC is congruent to BD. AC is congruent to BD. And so as you can see here, AC, right? AC is that diagonal, BD is that diagonal. We know the two diagonals are congruent, which sounds like a rectangle, but remember, what we don't know for sure is, we don't know that it's a parallelogram. So this would actually not be valid because we do not know that it's a parallelogram. We do know the diagonals are congruent, which sounds like a rectangle, but because we don't know the diagonals, we don't know that the shape is actually a parallelogram to begin with, we can't conclude that it's a rectangle. The next one says the same shape, but says given that AB is parallel to CD, AB and CD, okay, that's the top and the bottom line of the shape. AB is congruent to CD, so now the top is parallel and congruent. That should ring some bells. If it's parallel and congruent, that means the shape is definitely a parallelogram. And it says AB is perpendicular to BC. So now we know that that top line and the side over here are perpendicular, which because it's a parallelogram, that means that all the interior angles are supplementary, and if that's 90 degrees, that's 90 degrees. That means they're all 90 degrees. So, therefore, we can conclude that it is, in fact, a rectangle, because one pair of opposite sides are congruent and parallel, which means it's a parallelogram, and because it's a parallelogram with one right angle, therefore it's a rectangle. So that would be valid. Again, also these notes are also online. I know they're kind of wobbly here in my hand, but they are listed on my website, so you should be able to find the link to those. The next kind of question you're going to have is going to say, use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square. Give all names that apply. And of course, what we've talked about is the diagonals so far. So you need to, again, look at the diagonals. It's already telling us it's a parallelogram in the direction, so we already have that condition met. So all we have to do is check the diagonals. So we want to find those diagonals. We want to compare the measures of them using the distance formula. We want to see if they are congruent. Remember, if they're congruent, it's a rectangle. We want to compare the slopes of those diagonals. If the slopes are opposite reciprocals, that means they're perpendicular. If they are both, that means it's a rhombus. If it's both, a rectangle and a rhombus, that means it's a square. And so you can see the work here on number 4. It has these points, P, -5, 2, 4, 5, 6, -1, and -3, -4. I plotted the points there. Looks like I had an error there at one point. But what I did next was I found QS going diagonally there and PR. And I just plugged in the points, QS, and I found at the diagonal, that one is the square root of 130. PR, the other diagonal, is square root of 130. Therefore, because it's already a parallelogram and the diagonals are congruent, we know it's a rectangle. Now checking the slopes of those two lines, I ended up with -3/11 and 9/7, so therefore it's not a rhombus. If it was a rectangle and a rhombus, remember that technically it'd be a square. Number 5 is the same kind of problem. I'm not going to go over that one to go into more detail. This is just one example of some resources for you to help you with today's lesson. You can also check the online videos as well as maybe my notes if, like I said, I kind of went through these quickly and you'd like to take a closer look at my notes. But use those conditions that are in the chapter. So make sure you look in the book, check those conditions, make note cards because you can use them on the quiz. The quiz will be next week at some point, so keep that in mind. If you have questions, you can always email me throughout the day. I'll try to check them and get back to you as soon as possible. Have a good day.